So now let's go over something called the rate law, which rate law just basically relates the rate of a reaction to the concentration of the reactants, and those reactants will be raised to some type of exponent. Now the difference between this and what we did before is just, before we were actually comparing reactants and products. In this case, we're not going to deal with products at all. It's always just going to be the reactants. And for instance, if we were to have a reaction like the one that I have here, the rate law would just basically be your rate set equal to K, which K is a rate constant, and then you'd have your concentrations of your substances, and then any coefficient would become an exponent. Now this is if you're dealing with something called an elementary step. Usually though, you're given an overall reaction and you can't use the coefficients to be able to do out your exponents. You have to figure it out experimentally, which we will go over as well. So let's just assume for now though that we're dealing with an elementary step. So what we need to do in this particular problem is just figure out the rate law, and it's just simply rate equals K, which is a rate constant, set to your concentration of your reactants. So reactants in this case are H2 and I2, and now just make sure you put your exponents, which in this case both coefficient is 1, so that means your exponents will be 1 as well. So in this case, your rate law is just basically rate equals K times the concentration of H2 times the concentration of I2. Now again, in this example, we're assuming that we're dealing with an elementary step, so let's just figure out the rate law. So rate law is just rate equals the rate constant times the concentration of the reactants. So the first reactant is NO. You have a coefficient of 2 though, so make sure you raise that to a power. Then multiply by the other reactant, so it's H2. Again, you have a coefficient of a 2 in front, so make sure you put that as the exponent.